Creating functional and technical documents for a deep neural network, DNN, aimed at sales forecasting involves detailing the purpose, structure, and technical aspects of the neural network specifically designed for predicting sales. Pradeep K. Suri. Author and researcher. Chapter 2. Functional document. Purpose of the DNN for sales forecasting. Objective: state the goal of the DNN in sales forecasting, such as predicting future sales based on historical data, market trends, etc. Functional overview: describe how the sales forecasting DNN will assist in making informed business decisions, optimizing inventory, or planning marketing strategies based on predicted sales. Sales forecasting with DNN. Use case description: explain the context of sales forecasting using the DNN. Utilizing historical sales data, market conditions, and other relevant factors to predict future sales figures. Benefits: highlight the advantages of using a DNN for sales forecasting, such as improved accuracy over traditional methods, adaptability to changing patterns, etc. Example of DNN for sales forecasting. Scenario: forecasting sales for a retail company. Use case: predicting monthly sales for a retail store based on historical sales data, seasonality, promotions, and economic factors. Functional description: explain how the DNN will take in various data inputs and generate forecasts to assist in inventory management and sales planning. Technical document. DNN architecture for sales forecasting. Input data: describe the types of input data used, example historical sales data, marketing spend, economic indicators. Network structure: detail the neural network architecture designed for sales forecasting. Input layer: number of input features. Hidden layers: number of nodes, activation functions used, example LSTM, GRU for time series data. Output layer: predicted sales figures. Loss function: specify the loss function optimized for sales forecasting, example mean squared error. Optimizer: define the optimizer utilized for training the model, example ATOM, RMSprop. Training process for sales forecasting DNN. Data pre-processing: outline any data pre-processing steps, such as normalization, handling missing values, or feature engineering. Training parameters: detail parameters used for training, like batch size, number of epochs, learning rate, etc. Validation strategy: describe how the model's performance is validated during training, such as using a validation set or time-based splitting. Sales forecasting DNN example configuration. Architecture example: provide a simplified example of a neural network structure for sales forecasting, using Python and TensorFlow/Keras. Training configuration: show a sample code snippet demonstrating the compilation and training of the DNN using historical sales data. Python. Example DNN architecture. From TensorFlow.Keras.models import sequential. From TensorFlow.Keras.layers import LSTM, dense. Model equals sequential. LSTM, 64, activation equals relog, input underscore shape equals time steps, features. Dense, 1, output layer for sales prediction. Compile and train the model. Model.compile, optimizer equals ATOM, loss equals MSE. Model.fit, train underscore data, train underscore labels, epochs equals 10, batch underscore size equals 32, validation underscore data equals val underscore data, val underscore labels. These documents blend a high-level understanding of the sales forecasting objective with detailed technical specifications necessary for implementing a DNN tailored for this purpose. Adjust the specifics based on the nature and complexity of your sales forecasting project. Thank you.